Welcome to C++ Club meeting 149. Microsoft has released a new version of Visual Studio 2022, 17.2. For C++ developers, the main highlights are module support for CMake. You have to specify std C++20 or std C++ latest switch and use a MS-build generator for CMake instead of Ninja. Another interesting feature is inline hints that have been available for CLion and ReSharper for quite a while now, but now they come to Visual Studio. This is very convenient to see if you want to see a deduced type for your auto variable or see the function parameters. There are also some improvements for embedded developers. Another new thing is that STL completes C++20 support, and this is true for two versions of of Visual Studio, the newest Visual Studio 2022, and also Visual Studio 2019, version 16, 11, 14. Those version numbers are crazy. So this includes several proposals approved as defect reports by the standards committee. Next, we look at this article by Julian Jorge, which is comparing memory sanitizers. The author compares address sanitizer and Valgrind, and also products that I didn't know about, notably Dr. Memory, which is apparently an open source LGPL licensed memory error analyzer, and Intel Inspector, which I think it's a free tool as well. It's sort of a tool to analyze the build release binaries, not an instrumentation tool like Address Sanitizer, for example. The author used a set of buggy programs with a set of sanitizers, which interestingly included Memory Sanitizer from Clang. Normally, for best results, you would want to rebuild the entire standard library and any dependencies to use Memory Sanitizer efficiently and avoid false positives. But the author didn't seem to do that. He ran the test set on several different OSs and hardware configurations and produced a set of benchmarks. His summary is as follows. Quote, "The less efficient tool on this test set is Memory Sanitizer, which finds only 2 errors, as also reported by other tools. As I said, this could be related to the fact that he didn't rebuild dependencies." He continues, "Address Sanitizer X is excellent. Its impact on the execution speed is low. It finds many errors, including errors not found by the other tools. Valgrind and Inspector 2020 are as good as each other. They find the same errors, including errors not found by Address Sanitizer. Both are also very slow in the same order of magnitude. Inspector 2020 is the only good version of this tool. 2016 and 2017 could not manage to start the test. 2018 and 2019 report an error on the test where there is none. When running the tools on non-toy use cases, the program ran 3 to 13 times slower with Address Sanitizer and 163 to 565 times slower with Inspector or Valgrind." End quote. In the end, the author says that they switched to Valgrind in their CI from Intel Inspector. I mean, why not Address Sanitizer, I wonder, given this conclusion? My guess is they wanted to check the existing release build and avoid having to produce a new instrumented build for ASAN. There is a Reddit thread which has some useful information, like, for example, this set of ASAN options that you can use. GCC 12.1 released. Quote, the GCC developers are proud to announce another major release, GCC release 12.1. This year we celebrated the 35th anniversary of the first GCC beta release, and this month we will celebrate 35 years since the GCC 1.0 release. End quote. The main highlights of this release are initial support for CTF debugging for format. It looks mainly relevant to C, not C++. CTF is compact C-type format. Improved C++20 support. Still no modules though. And improved experimental C++23 support. There is an article on the Red Hat blog which outlines the new C++23 features in this version of GCC, like, for example, if const eval, auto x, which allows auto in a function style cast, the result of which is a pure R value. Non-literal variables in const per functions. Multi-dimensional subscript operator. I know some graphic programmers waited for this. The new preprocessor directives elif-def and elif-and-def, extended init statement, and some other corrections and internal improvements. Another new thing is that vectorization is now enabled at -02 optimization level. This is since GCC 12. And another interesting feature is that now it supports the mold linker by default. The mold linker author Rui Ueyama tweeted, "This is the first version to support fusld equals mold to use the mold linker." It's a bit funny that GCC now has a dedicated command line option for my mostly single-person open source project. To be fair, it's a pretty impressive project and is probably going to be pretty significant. There is a full set of changes on the GCC website, including a separate section for C++. There is a Reddit thread on this GCC release. The Redditors are unhappy at the lack of modules progress and the absence of support for std format and std chrono calendar support. From the thread, I gathered that it looks like Nathan Sidwell is the only developer working on GCC module support. The whole compiler and language development situation is a mess, a Redditor says. Quote, "It's always been bizarre to me how, despite C++ being one of the most incredibly widely used languages, the amount of manpower available to the language and ecosystem seems to be relatively low. Even the whole committee process is all done by volunteers with very limited time. It's strange." Tristan Brindle says, "I do find it quite strange that given the amount of money in the C++ ecosystem, big tech, financial firms, etc., and given the increased developer productivity that would result from faster compile times, no one seems to be making modules a priority. Everybody wants it, but no one wants to pay for it. But Google or Apple could probably recoup the cost of a developer over the course of a year just in power savings from making WebKit and LLVM compile faster." Regarding contributing to GCC development, this Redditor says, "I'd love to contribute, but the last time I browsed the GCC source code, I opened a portal to hell." And regarding Google's contributions to compiler development, another Redditor says, "Folks here have said that Google stopped contributing to Clang so much. once they couldn't get support for changing and breaking the ABI. Now they do stuff with libraries like Abseil instead. They've also been doing a bit more with Rust. So yeah, not very encouraging. This is another thread on Reddit about new C++ features in GCC 12, which starts with, "Modern C++ is becoming so good, it almost feels wrong when you experienced C++ 99 and prior, getting such high-level features while keeping the performance and everything. Love it." Next step is to get proper dependency management, and we are golden. Yeah, about that. Right, next on my list is Lexy, a C++ parsing DSL. Jonathan Müller wrote this library called Lexy. It's a parser combinator library for C++ 17 and onwards. It allows you to write a parser by specifying it in a convenient C++ DSL, which gives you all the flexibility and control of a handwritten parser without any of the manual work. This is an example IP version 4 address parser. Lexy is similar to other PEG parsers, like Boost Spirit. The main difference seems to be that Lexy doesn't do any implicit backtracking, thus giving the programmer more control over parsing. There is a nice online playground that the author created, where you can define a grammar and try parsing a bunch of text using that grammar. And what's interesting about it is it shows you the sort of a tree that is the result of parsing. It's very interesting. It's a bit slow though. The library is on GitHub using BSL 1.0 license. Next on my list is C++ debugging in Visual Studio Code. A new article dropped on the Microsoft Visual Studio blog, in which Julia Reid describes C++ debugging support in Visual Studio Code. The main news are there is now a native support for Apple's M1 chip, data breakpoints when debugging with GDB, which is really cool. There is a caveat. As it uses hardware breakpoint support, the number of data breakpoints you can have at any one time is limited to around 4. Depends on the CPU. Another nice improvement is a quick run debug button that allows running debugging a single C++ file without having to edit launch JSON file. Editing that file is not a big deal, but if you can avoid it and just run a snippet of code, that's very convenient. Nice to see improvements to one of the most popular code editors, which is now closer to a full-fledged IDE. Here is a useful tip from Victor Chura. He says, "I've been using cppreference.com for years, and just a few weeks ago I found out there is an advantage to actually creating an account. You can filter different versions of a particular function, data structure, or algorithm based on your target C++ version. That can be really useful when you are limited to a particular C++ standard." Next is one of those articles on Reddit. Currently, what are some of the worst things about C++? Main points from the thread. I won't scroll it because it's a lot. Those threads usually are long and have various sub-threads that are useless. But the main pain points are, as usual, setting up build tools and system, especially for a new cross-platform project. In other news, CMake init is a special tool to initialize a new CMake project. And that tells you something about the usability of CMake. You need a special third-party thing to make it easier. Backward compatibility, which is also a best thing. ABI stability, or in other words, if only we had epochs like Rust. Bad teachers, bad books, bad tutorial sites run by content farms, and bad videos resulted from Dunning-Kruger effect. C developers who constantly shit-talk C++ features as if someone is going around putting guns to their heads and threatening to take away C. Long build times, lack of built-in package manager, header files, lack of Unicode support, slow standardization process, the amount of pitfalls that you have to remember to avoid. Quote, "It's baffling to me that you can write ill-formed code that may or may not give you any errors at compile time, and the program may do something, but what it will do is undefined." Another quote, "People who complain about C++. Also, the enthusiastic Rust people who show up for on C++ fora. Rust is its own thing, better in some ways and not as good in others." And the winning comment is, quote, "The worst thing about C++ is the monthly 'What do you hate about C++ thread here on RCPP. I agree. Next is an interesting thread on Reddit. Started with the question, what's your favorite way to crash your application? Interestingly, his example is not guaranteed to crash, as we saw earlier. Dereferencing a null pointer is undefined behavior and not necessarily a crash. As another Redditor says, "I've worked on at least one platform where writing to address 0 does not crash the program. The optimizer is also free to remove memory writes that are never referred to later." And they say, that should crash just about anything. It's a bit of code to unwrap, actually, despite the fact that the Redditor says, "Most of the time I'm boring and use std abort." His code snippet is interesting. He chose the Avogadro number, this one, to divide it by 0. They explain all the choices later, and this is a quote. "It's well known, the Avogadro number, it's well known and has nothing to do with systems programming, so long as the program itself doesn't have anything to do with chemistry. It's a sign that something strange is going on. It's too large for the compiler to emit it as an immediate, so it must be loaded from the data segment. It's a floating number, floating point number, so x86 can't divide it with IDIV instruction. It has to get transferred to the FPU or SIMD unit. And they're really picky about alignment, so the addition will bomb. And finally, the goal here is to crash even if FP exceptions are disabled, by forcing a bad memory access that the compiler can neither inline with immediates, nor elide because it's marked volatile, with the optimizer turned on. Doing just what the original poster did will often be removed by the compilers running with optimization. There are some other choices in this thread, namely std terminate, std abort, std raise seekterm, std exit -1, and the compiler built-in equivalents of exit. There is also like a deferred crashing, which is a piece of assembly where you move 0 to the SP register. I think it's stack pointer. There is also a Clang built-in trap function with the added bonus, which is this produces a 2-byte UD to A instruction on x86-64, and the attribute prevents optimizers from merging it together, so you get distinct source location in your crash reports. And this snippet that you see works, or rather crashes, on ARM microcontrollers even before the memory is accessed. They say LSB is 0, which means trying to enter the deprecated ARM state. This will crash the CPU before even trying to access the memory at address 2. Some commenters suggest using assembly int3 instruction or a debug break function built into compilers, which breaks into debugger or crashes if there is no debugger. And the winning comment was at the beginning of the thread, quote, "Just running it usually does the trick." Next, we'll see a library for game development, which is called Box2D. It's a feature-rich 2D rigid body physics engine for game programming. Quote, "It has been used in many games, including Crayon Physics Deluxe, which was the winner of the 208 Independent Game Festival Grand Prize. Box2D was created by Erin Kato of Blizzard, soon to be part of Microsoft." How did that happen? As part of a physics tutorial at the Game Developers Conference. There is a fair warning on the documentation website. Quote, "Since Box2D is written in C++, you are expected to be experienced in C++ programming. Box2D should not be your first C++ programming project. You should be comfortable with compiling, linking, and debugging. Box2D is on GitHub under MIT license. It builds using CMake on Windows only with Visual C++ and can be installed via VC Package Manager. Ports are also available for Flash. What's Flash? Java, C#, and Python. It has its own subreddit and a Discord server. So if you're trying to do some simple 2D game development, I guess that is one of the options. Right, let's look at some more UB. Just yesterday, I think, Colby Pike, who is also a vector of Boole on social media, wrote this article, Mysterious Memset. In it, he illustrates the effects of UB on compiler optimizations. Consider this simple function. It takes a pointer to a count, which is int. The detail is important. It has to be a pointer to the count. And the second argument is a reference to a string. Then there is a loop where all elements of the string are assigned 0. He says if we feed this program to an optimizing compiler, the machine code is roughly equivalent to the following. It's pretty much just checks if the count is not 0, and the rest is as you'd expect. Now, if you do this change, if you use not stud string, but stud u8 string, which uses new char8 underscore t character type, what happens then? This happens. The entire loop is replaced by a memset. But how? What happened? He says, spoilers below, spoilers below. To summarize, this is because assigning to elements of a stud u8 string cannot affect the passing count, the passed count. The reason for that is that previously in the normal string, its type is a pointer to char, which has a special superpower in C++. You can use it to alias anything. It's probably from the C days where you had to play with byte data of objects. So when optimizing the original code, the compiler has to assume, provided there's no appropriate compiler switches, that the count can be aliased, and assigning to elements of the string can change the count because it can be aliased by any of the elements because they are pointers to char. However, using anything else to alias in C++ is undefined behavior, so the compiler assumes it never happens. And so, since count is now a loop invariant, the whole loop can be turned into a memset. Yeah, lots of interesting UB things that you have to be aware of. This meeting is going to end soon, and I will leave you with this tweet that shows a screenshot from Reddit. Quote, Will software engineers ever stop being in demand? There are two schools of thought. Those with a background in business see developers as commodities and fully believe that programmers will program themselves out of a job field. The idea is that in some distant future, jobs like project manager, product manager, and marketing manager will still be critical, but programmers themselves will be extinct as a result of the tools they created. The other school of thought is hard to understand because the programmers are laughing so hard they can't talk. That's it. Thank you very much for attending this first public meeting. Thanks, and until next time. Bye-bye.